Okay, this is a lab today called the friction lab, and we're going to compare the coefficient. We're going to calculate and compare the coefficient of friction between two different surfaces, okay, and also compare it between two different areas. So we're running basically two different experiments today. And then once we get done with the two experiments, we're going to draw some conclusions from that. Okay, so we're going to do a group of measurements, and we're going to make 4 tables. Okay, I'm going to give you the input data. I'm going to actually do the experiment. You're going to watch me do it live, and then I'm going to fill out the experimental, the measurement part of the table. Then you're going to do the calculations and do the questions. Okay, so let's start with that. So first of all, let's start with the first one. We have 2 tables, table 1 and table 2. And basically this table 1 and table 2 is a comparison between surfaces of different roughness. Okay, so I've got a rough board here. This is a rough wooden board. I picked a rough one on purpose because I want a lot of friction. Okay, I don't want it really to be too smooth. And then I have a smooth wooden block. Okay, a smooth wooden block. I'm gonna look at moving this smooth wooden block over this wooden surface, and I'm gonna get the coefficient, or we're gonna try to measure the coefficient of friction of that. We're gonna compare that to a second block where we look at the same size block, same thing, except it's gonna be covered with sandpaper. So this sandpaper is rough compared to this wood, which is smooth. They're both gonna be run over this surface. Okay, so that's the first comparison I'm gonna make. The information I'm going to get for table 1 is going to come from here. Table 2 is going to come from here. So let's do table 1 first. So what I'm going to do is so first off, let's start with the table. Let me fill it out. We're going to do table 1. So we're going to do table 1. It's going to be the wood on the tabletop, this thing right here. And first of all, I'm going to tell you right off the bat so that you know, is that the table, I've got to find my number here. The mass, you're going to need the mass of this box, the wooden box, okay? The mass of this wooden box is 126 grams, okay? I'm going to do 3 cases. I'm going to add to this box 3 different masses, okay? 100 grams, and you can see that on here, it says 100 grams. I'm going to add a 100 gram case, a 200 gram case, and a 500 gram case, okay? So my first case will be 100 grams plus 126 gram box plus 100 gram weight, okay? The second will be 126 grams plus a 200 gram weight. And the last one will be 126 gram box plus a 500 gram weight. You're gonna need to convert that into kilograms by dividing by 1,000, okay? So that will be the same for all of these tables. Okay, so I'm not going to go back through that in each case. So when you do the other tables, table 2, 3, and 4, you're going to use the same numbers here. Okay, so do that once and just repeat the numbers over and over again. Okay, and I'm going to let you do that. Okay, the next thing we're going to gather is we're going to get the LabQuest data. Well, that data is how much force I have to apply. It's an applied force that I have to apply to move the wooden box. Okay, so I'm going to start with table 1, and first off, I'm going to start with the wooden box with the 100 gram weight. Okay, now I've got to make sure I calibrate this so that it's sitting right on 0 here, and what I'm going to measure is the Newton force that I need to pull this box across the wood, across this wooden surface at a constant velocity. Okay, and I calibrated it, so I'm going to go ahead and pull it, and I'm going to measure that at a constant velocity. So I'm pulling it now, and it looks like it's 1 Newton. Okay, so the LabQuest reading in newtons is 1 Newton. Okay, that's the first one. Now I'm going to do another one. Go back, set it up again, recalibrate it each time, because we have to do that because these are really not terribly complicated spring scales, right? These are not super great, but they work, right? So I'm going to pull this one at a constant velocity. This is 200. Okay, this is about 1.3 newtons. Okay, and then the last one, 500. Recalibrate again. This is the smooth block. This is a smooth block, wood on wood. Okay, that's pretty good too. That's about 2 newtons. Okay, so you can see I've got the applied pulling force for each of these 3 cases. Okay, now I'm going to compare that. I'm going to leave the area the same. I'm going to compare it to the sandpaper. Okay, so then that's table 2. Okay, so we'll set that up. Okay, table 2, and we're going to do the weights again. So the same weights again. Okay, so again, I'm not going to, let me write them down just so you know. This is 126 plus 100. This is 126 plus 200. And this is 126 plus 500. Okay, I'm not going to write all the units and all that stuff. Okay, let's pull them and see how they do. Okay, pulling. I've got to, sorry, I almost messed up. I've got to add this weight to it. Here we go. Wow, this is a lot harder. Constant velocity is hard to do with this. Okay, that's really great. It's now 2. Okay, that's 2 newtons. Okay, now let's go to the bigger weight. Recalibrate. That looks pretty good. Let's recalibrate and let's go again. Constant velocity. Okay, 3 newtons. Okay, last one, the big guy. Recalibrate. Boy, this is going to be tough. I don't even know if we can pull this. Maybe not possible. Whoa, look at that. Oh my gosh, 5.5 newtons. Wow. Okay, so let's do a little quick comparison. We looked at the same masses, the box in each case, 100, 200, and 500 gram masses, okay? And you see the pulling force. You can see here it's about double, here it's about double, there it's more than double, okay? So you can see that's the amount, that's the difference in terms of the roughness of the surfaces. One's relatively smooth wood, the other one is covered with sandpaper. That's the difference, okay? So let's go to the next table, table 3. Well, table 3 is just a repeat of table 1. Okay, so you don't have to redo. There's nothing to do for table 3, and I'm not going to fill out table 3. Take the data from table 1 and put it in table 3. Okay, copy of table 1 on the large side. Okay, do that. Then let's go to table 4. That's going to be the difference. So we're going to use the same data. Okay, if you recall, on the first table, we took a big area, a large area, and we moved it on top of this rough table surface. Well, now we're going to compare 2 different areas, a large area and a small area, okay? And so what we're going to do, we're going to use the side this time. So we're going to turn it on its side, and we're going to use the same weights again, the same 3 cases. So everything else is the same, okay? Everything else is the same. So let's try with first we're going to go with the 100 gram weight. Okay, and that is about 1.2. Ah, 1.2. Okay, and now we're going to try the 200. Let me recalibrate it. It's hard to calibrate this. Okay, there we go. Here we go. And that's about 1.7. And then the last one, let me recalibrate it again. Good grief. And about 2.7. Okay? Okay, that's it. So what you're going to do is now you have all your data. You're going to calculate first. This says FW, but in this class, this is FG. This is the gravity force acting on the box with the weight on it. Okay, and you can calculate that. That's the FG. Then once you have the FG, you know this is the pulling force. Well, because it's moving at a constant velocity, the pulling force is equal to the friction force. Okay, and you can get the coefficient of friction by dividing the friction force divided by the normal force. Okay, that'll give you a coefficient of friction. add those all three together, okay, divide by 3, get an average for each table. And then we're going to talk about the results. Okay, go for it.